Hey guys, we're going to be looking at some examples on how to solve quadratics with i's. So I stands for imaginary number, because in math you cannot have a negative square root. There cannot be a negative number underneath the radical. So how we're going to get away with this is we're going to rewrite it as 9 times a negative 1, because 9 times negative 1 will give you negative 9. Okay, now we have the square root of 9, which will give you 3. And here's where the I is going to come in. If you have a negative 1 under the radical, you pull it out and just say I. So the square root of negative 9 is going to be 3i. Let's look at another example. We have the square root of negative 5. So once again, how we're going to rewrite that is 5 times a negative 1. Okay. Over here, we cannot simplify the square root of 5 because you know that is not a perfect root. So we're going to rewrite it just as the square root of 5, but we can take out the square root of negative 1. Okay, we're going to pull it out and we're going to put I. So like in example 1, when what's under the radical is a perfect root, so you pull it out and you get rid of radicals altogether, the I will go on the back side. If in the problem you still have a radical, you're going to have to put the I on the front of it. Okay. So the square root of negative 5 is the same thing as saying I square root of 5. Let's look at one more example. We have the square root of negative 80, which of course will be 80 times a negative 1. Okay. We can break down 80. So keep in mind, we always want it like in simplest form. We can rewrite 80 as 16 times 5, and then of course times our negative 1 because we cannot forget that. Okay, so the square root of 16 is 4. We can pull that out. Square root of 5 is going to have to stay the square root of 5 because, well, we can't break that down. And then, of course, our our negative 1, becomes I. So this one, so like up here, how our I is in front of the radical, if there's a whole number that we also pull out, that's going to go in front of the I. So this will be our final answer. So now that we've gone over these examples, let's look at some problems where we're actually having to solve for x. Okay, so this one, keep in mind when you have a square, in order to take the square root of both sides, first we have to get x squared by itself. We have to isolate it. So we're going to start by subtracting 81 from both sides. Now we're going to have x squared equals negative 81. We want to get rid of that squared, so we're going to take the square root of both sides. That just becomes x equals, then we have the square root of negative 81. We know we're going to rewrite that as the square root of 81 times a negative 1. We know the square root of 81 is 9. And we know that the square root of negative 1 is just I. So this one, since we're actually solving for x, our final answer, we're going to say x equals. Keep in mind when you're solving for x on a radical, you always have a positive and a negative version. And then 9i. So this right here would be your final answer. Let's look at another example. Once again, we have to isolate this. We have to get it all by itself before we can take the square root of it. So we're going to start by subtracting 13 from both sides. We're left with x squared equals negative 12. To get rid of our squared, we're going to take the square root of both sides. We're left with x equals the square root of negative 12. You know by now we cannot have a negative square root, so we're going to rewrite that as square root of 12 times a negative 1. So the square root of 12, obviously that's not a perfect root, but we can break it up using perfect roots. We can rewrite 12 as 4 times 3. And once again, I picked 4 times 3 because 4 is a perfect root. And it's still times a negative 1 because we cannot forget about that negative 1. Okay, square root of 4 is 2, so we're going to pull that out. The square root of 3 cannot be broken down, so it's going to stay square root of 3. And then, of course, the square root of negative 1 is I. And then once again, because we're solving for x, our final answer is going to be x equals plus or minus 2i square root of 3. Okay, and that'll be your final answer. We're going to look at one more example. Same concept, so we're just trying to get x all by itself. Once again, we have to isolate it before we can do anything. So I'm going to start by adding 5 to both sides. We're left with 3x squared equals negative 441. Then we're going to want to divide both sides by 3. We get x squared equals negative 441 divided by 3. That's going to give us negative 147. Okay, now that we've gotten our x squared isolated, we can take the square root of both sides. The square root cancels out the squared, so we're left with x equals the square root of negative 144. Once again, you know by now we rewrite that as the square root of 147 times a negative 1 equals, and now the square root of 147, we can break that down because we always want it in its simplest form. 147 divided by 49, I believe. Yes, so 147 is the same thing as saying 49 times 3. I used 49 because you know by now that that's a perfect root. It's still going to be times by our negative 1. Okay, so the square root of 49 is 7. The square root of 3 is 3. Square root of 3, we can't get rid of that. And then of course the square root of negative 1 is I. And once again, we're actually solving for x in this. So your final answer is going to be x equals positive or negative 7i square root of 3.